Welcome back to my series on MLflow for GenAI platform. Now, in the last episode, episode 3, we covered or introduced into MLflow tracing, where we actually used a single line of code, MLflow.library.autolog, that gave us the ability to record all the interactions, all the operations that your agent is going to perform. This would include, for example, what LLM was called, what model name was called, what were the latency of that particular call, what were the input, what were the output parameters, and how much tokens were used in each and every trace, along with the cost usage of that particular trace, along with any other arguments that you actually might do for logging. But what about if you actually want to cover additional functions which are not covered by autolog, such as you have a tool usage or you have a RAG application that you actually want to trace? That's where the manual tracing come in. And this particular episode, you're going to concentrate on advanced observability with manual tracing using custom span decorators that we will explore. And this allows you to trace complex workflows, which are very typical in the agentic workflow, how you can actually debug some of those tracing with those manual traces, and then explore a couple of multi-step agentic patterns, which are very common. And then the last bit, I'm going to let you do an exercise on how you can actually use the trace to use the MLflow assistant to debug and to find out the root cause analysis, which we covered in episode 3. So if you actually haven't used or watched episode 3, I suggest you actually do this at this point. So what are you going to learn in this particular tutorial or in this particular episode? For one, we are going to concentrate on MLflow trace decorator along with some of the arguments that you can actually send. We are going to define about 7 different usage span types that MLflow provides you to label your particular tool usage or a span. And then we use 2 different agentic workflows. One is how to actually use tool usage as one of the agentic workflow. And then we're going to use a RAG pipeline end-to-end to see that. And then we'll look at how you can actually use some of those traces for debugging, as well as use the Claude Assistant to inspect your traces and then find for root cause analysis. Prerequisite for this particular notebook: make sure that you actually have 1.3, which is the 3rd episode, understand how autologging actually works, and familiarity with the ML UI. This is going to take about 30 minutes or so. So again, to repeat, when is it that you actually want to use manual tracing? Autologging is actually great for if you're making LLM calls to the Anthropic or the OpenAI or any of the foundational providers. If you're using integrated frameworks such as LangChain or LangIndex or LangGraph, where you can actually use just one single line of code to capture all the information that you need. And it's good for quick prototyping to find out what are the traces revealing you, which are very typical of standard workflows as you interact with these LLM providers. But more importantly, when you actually want to use manual tracing is when you actually have custom functions in your pipeline, and which is very a common case. You have some domain-specific operations that you're using that could be parsing a particular query, you might be validating a query, or there's a business logic that is not captured by Autolog. This is where the manual tracing comes in. And we're going to be using or defining some custom retrievers for your data source that you can actually use using this particular function call, or any external APIs that you're using, or any other additional context that you actually want to add. This is where the manual tracing is actually quite needed. And the strategy is very simple. You want to use both. And the way to use that is enable MLflow, the library name. In this case, I'm using OpenAI, Autolog, early in the code, as well as for more granular capturing of the custom logic. You want to use the MLflow trace decorator above your function, whichever the function it is, and give it a particular name, a descriptive name that defines that particular function, and the span type. Now we're going to go into what the span types are. So I'm just going to go ahead and do my usual thing over here. In the first, I'm going to go ahead and establish my setup environment, which now tells me that I'm using my local server as a tracking host, a version 3.10 of MLflow, and I've configured OpenAI client to use my as my provider. Now, manual step tracing has MLflow defines about several different types of MLflow tracing. One is the chain. As you can actually see, the chain is a high-level operation or high-level span that you can actually normally use when you're defining a parent operation as a wrapper. You could have LLM calls within that particular chain. This is making a call to the language model. You could have a retriever, and retriever is a general document retrieval function span that you actually might want to tag your function as. And text embedding, if you're building a reg application, it is part and parcel of it. So this is where the embedding can be used to create a vector of floating numbers that you can actually send to a vector store. And tool is just a normal function that you're actually going to execute. So if you're actually using a tool, say that you've written a custom tool to talk to a web service or talk to a local database, this is where you allocate that span to be of type tool. An agent is, again, another high-level span that will start planning a particular process of how your task is going to be accomplished. And based on the particular query, it will decide how to go ahead and execute that particular query. So that could be sort of your span that's an agent. And last but not least is parser. Parser is generic, allows you to parse any particular query or any output that comes from a business logic call that you can now customize it, or you can parse it, drop some of the things. This could also be a good way to somehow obfuscate or mask any of the PIA data they actually might have. So how do you use those standard span types? Very simple. Your MLflow trace decorator can take two arguments. One is the name, which should normally be a retriever, should normally be a name that defines or captures what the function is doing, and then the span type. In this case, I'm just using a retriever. So given those particular seven types that we actually have over here, let's see how we can actually use each of those in some of the functions that I'm going to define, and then run those functions to see how they are recorded in the UI. My first function is called simulate custom query processing. And this is, again, I'm just simulating a database query simulation where I'm going to start this as my change, as my top level span. And I'm going to simulate as if I'm talking to a database. This could be your production SQL database, could be Lakebase, could be Postgres, or whatever it is. In this case, I'm just using, for the purpose of illustration, the SQLite, and I'm going to create a particular connection. I'll insert this particular query. I'll simulate as if I'm making a call to the query, and I'm going to select something from a particular table, and I'll return the value fetched from the customer. It's actually doing a very simple database query. This could be something very similar that you might be doing. Another call that I actually have, a function that I defined it as a parser, is process query. And process query, as the name suggests, is just going to invoke simulate custom query processing by making a call to the upper level. And this is going to be defined as a span type. And then I have another function called get embedding, which is going to actually create an embedding for my query, which is going to go talk to the text embedding three small OpenAI embedding LLM, and then return me a float of vectors that actually is then send it to the vector database, and then embed query just calls embedding. So these are a set of functions that I'm going to define with the particular span type, and then see what it actually looks like. Now we're going to try to see what it looks like when we actually execute this particular functions using the manual tracing. So the first one is going to be process the query. Well, I'm just making a very simple query, such as what is MLflow, and is going to process the query, will insert in the database, get that particular queries, parse it, and then return back. And the second query is, what are the MLflow's tracing capabilities? And here I'm going to embed that query because I want to use this particular query to make a call to my vector database with that floating vector of embeddings to see what are some of the closest documents that will match that. And then I'm going to retrieve the documents, and I'll ask, here's my query. Here are the top 2 documents that I want. And I'll enumerate all the documents that I have. And then I'm just going to go and send that to my entire answer, that these are all the documents that were actually retrieved. So let's go ahead and run this particular set of queries and see what actually happens. So as you can see, I did process the query. This was how it parsed the query and returned me everything in lowercase. Then I used that particular query to create an embedding, and I got my embedding as a float of vectors. Then I queried my documents using a vector database, sending in those queries, and I got those 2 relevant documents. And then I printed this out. Very simple, very easy. But the whole idea over here is that you have now more control over what information you're sending in and out of the function call, and you have more visibility into how that function process. So if you go to the UI, you will actually see that I made 3 calls. This is my top level call, process query. I actually made, you can actually look at the input output. I can look at how long it actually took for each and every function within that particular query to establish. I can see my inputs and outputs. I can go to my second one and then see the same thing. Over here, I'm doing a query embedder first. Here is my outputs that I got from the query embedder. Then I get my embedding. This is what I got from my embedding. And then the third one is I'm making a call to document retriever where I give the inputs and outputs. And these are the outputs that I got returned. So that's very simple. We're going to collapse this and then now add some custom attributes. Why would you actually add custom attributes? And this is quite common practice whereby you actually might want to somehow capture some relevant metadata and attach that to your functions or to your span. So later on, you can actually do some analysis. And the way you do that is that you take the current active span that you actually have and set some attributes that you actually want. You can do that before the call and after the call. And this way you have an idea of what was sent in and what was returned as part of the metadata. So as an illustration, I have an enhanced retriever that I've just modified a little bit. And here's my query that comes in and I'm saying, go ahead and return me the top 3 documents that actually matched. And this, I'm going to call that span a retriever. So I get my current span. As you can see, this is my current span. I set the attributes over here by using that particular span handle. I now simulate by making a call to the actual vector database. So this is what my sleep statement does. And I got returned a set of documents that came in. And now I'm going to set the attributes post call. So that way I know what went in and what came out as part of my documents. And then I return the top K documents from that particular call. So let's go ahead and run this and see what happens over here. My span was created. As you can see, enhanced retriever. I got my input and output, and these are all my attributes that I actually stored before and after. So that way I can somehow search in my traces for certain attribute type, and that gives me more visibility into it. Bottom line, when would you actually use custom attributes? And custom attributes are actually important because they give you additional information about metadata. Say you have some configurations that you actually want to store for your retriever, such as top K documents or the model name that you use for the embedding. Some performance metrics, such as number of the results that were actually returned. What were the cache hit if you were actually maintaining some sort of a cache? What were the data characteristics? How much was the query length? How many documents are in return? What was the size of the documents? There might be some business logic that you actually might want to somehow capture, such as what tier level of that particular business logic. You touched upon some of the feature flags they actually might have. And more importantly, some debugging information, such as the version of the particular file or the data source that you actually used. Bottom line, traces are searchable and inalienable if you actually have some custom attributes associated with that. Okay, having said that, now let's go and use everything that we have learned above in terms of the decorator and use in one of the most common agentic workflows, which is tool usage. Now, it is very important that you get this because you will be writing workflows that will be using some tools such as making a call to a database or making a call to an external web service or sending an email or doing some number crunching, talking to a particular database. So this is some way of saying, how do you actually take all these tools that you actually have at your disposal and create a workflow so the agent can actually know exactly what tool to call, what parameter to send in, and that way you can actually find out more about it when you actually run the trace. So I do have my get weather function over here, which is just simulated way of doing something. I'm getting my current span. I'll set my attributes over here to be the city that I'm asking for it and what the API version of the web service that I'm using. This would be the actual call to the web service using the API and the keys that I need. And then this is the simulated weather that actually came back. And I then set the attributes again after the call and then return the weather data. Similarly, I might have a function called create a calendar invite, which is very typical when you're actually doing some sort of a mundane task where I have now the span type of type tool and I create set the attributes for the current span to these are some of the things that I want to capture. I'm going to make a call over here to my calendar using the API and then return the values that I want it to be used as part of the arguments. And then finally, I might have a send mail tool function that I actually want to use to send mail to my team about a certain meeting and certain agenda that I have. And then finally, I might want to generate some password randomly to share with some people. And this would be sort of a good way to, create the particular tool that does that. Here's the gist of what's actually happening here. Agent Planner is the one that's going to actually take the particular query, parse that particular query, send a request to the LLM to say, here are the tools available for you. Here's the query that the user actually wants. Extract to me what the tool should be used and what should be the parameters used, and respond that with the JSON object that gives me the tool name and the parameters in order for me to call that. So this is a call to the LLM that will parse the query, and based on the tools available, it will go ahead and create this particular JSON object that has a tool name along with the list of arguments that it should actually use. So that's what this particular call does. And then run agent is the runner, which is the top level chain that's going to invoke all these function calls depending on what particular tool was used. So here LLM will pick the right tool because I'm asking it to go ahead and plan my agent or plan my query, what tool should be called. It will return back with that particular dictionary, and then in there I'll have the tool name. And here is where the thinking is actually going. Depending on what the tool name was based, I'll go in and make my appropriate function over here based on that. Once that's actually done, I'm going to go ahead and do the last one where the tool completion is complete, and I'll generate the answer of how the tool was used. So let's go ahead and do this. Now here we actually use the agentic workflow, right? I'm going to test my entire agent for 4 realistic queries. Get the weather in a particular city, schedule a meeting over here, do the query for sending an email, generate a random password, and then I'll run that. So let's go ahead and run this particular thing. And what I'll see over here is a flow of the agent making a decision to say, okay, here are the query of weather in San Francisco. It will actually create a nice response and send it back. The next thing it's going to do is generate calendar invite for people and send that particular as a message. And then finally, give you the calendar invite that you actually have. And then the last bit is the planning document. Okay. Once that's actually done, you'll see that I actually have completed my entire agentic workflow, ending with the last thing that actually does the planning. And here's my, here's my trace in the particular UI. As you can see, the agent execution is top of the chain. It's made a call to the LLM saying, go ahead and tell me what tool should I use. And I'm going to use a weather tool because that's what the agent actually told to use. The get weather is a tool, and here are the parameters you're actually going to send. And the weather tool was actually called with the temperature being 72, condition, all that. That's the return value. And the attributes are something that I set that is a good way for me to somehow keep track of what things that I'm more interested as part of the metadata. And then the second call was create the calendar. As you can see, the user query was this. And I am scheduled a particular meeting. The third one, I believe, was send an email, and this was my input. And here's my output, and the message was sent with the meeting notes. And then finally, the fourth one was generating a password. So as you can see, this is a good way to use the MLflow trace manual decorator to have more control over some of the functions that you might be using in a typical tool user scenario. So what are the benefits? Very simple. You actually get an insight into which tool was chosen and why, and you can actually look at the input and output of the parameters. That gives you more lens into some of the things happening behind the scene. Tool performance is a good way to find out how long it actually took each and every tool for latency. So that way you can actually know which tool is taking too long and what can you do to debug and improve the performance. If there's an error, you will actually see which tool actually failed in the entire chain. And cost analysis would give you some sort of how many tokens were used per particular run. And that way you can actually find out, can I use a different model for that rather than using a big one? And then this is where you actually go through the optimization. So essential debugging for complex agents if you're using a bunch of tools. Now, What we've done so far is that we have defined we have learned there are 7 different types of spans that you can actually use. All those spans can actually be used to create a chain of operations within the span that you're going to use. You can actually create a hierarchy of those particular span, and those are quite common in agentic workflows. The next thing I actually want to do is now use the same thing that we have actually learned and apply that to a complete RAG pipeline with the hierarchical tracing from top to the bottom. And this particular pipeline typically comprises of, you have a particular query, what is this particular document, or how do I actually do this? And it's going to take that particular query, parse that, find what the intent is, create an embedding of vectors, create a particular prompt format, call the database, vector database to get the information, format the prompt, and then finally send all the documents, relevant documents sent along with the query to LLM to generate the final response. So these are the set of functions which kind of define our entire end-to-end pipeline. So I have my parse query, as the name suggests. It's going to parse the query to say, what is it the user is asking? What is the intent? What is the entity that it wants to extract? And this would be the LLM call that actually extracts the entity, which is parsing the query. The second call over here is embed the query. We saw that earlier. All it's doing is taking the particular query that you actually have, which is now parsed and pristine, and it's going to create a vector of floating points, which then you can actually send to your vector search with the embedding to say, go ahead and return me 3 sets of documents which are most relevant to the particular query. So this is going to be something that you would normally talk to a vector database such as ChromeDB or Pinterest or Pinecone, or even if you're using a Databricks vector database, this is where the database call comes in. And it will return you a set of documents which are relevant to the particular query. And I have another function called format, which is of type parser, and it gets a set of documents and it's going to create a prompt and put the query together and put the context where all this return, and then send it to the LLM to generate the particular response. This would be sort of where the response is generated. This particular function is actually the final RAG that's going to run this particular end-to-end operation. So the first thing I do is I get the current span, and I'm going to set my attributes to be, this is the pipeline, this is version 1, and here's my particular query. So I start with my chain. I start with my parse query. Once I get that, I do my embedding. Once I get my embedding, I send that to the Doctor vector database to get my docs. Once I've got the relevant docs, I'm going to take the prompt. I'm going to take the user query and the docs, and I'm going to create a final prompt and then send that prompt to LLM to generate the final response. Okay, so these functions are defined, and let's run this particular end-to-end pipeline. So this is going to be my one call that triggers and starts the entire RAG pipeline end to end. And when I run this, all I'm doing is making this particular one call at a time in this particular pipeline, starting from my chain, which is the top level chain. I'm parsing the query, I'm embedding the query, I'm then searching the vector database to get the query relevant documents. I'm now formatting my prompt along with the query and the return documents, and I'm sending that prompt to LLM to give me the final answer. And what's actually happened over here is that you have now created a hierarchical tracing that gives you a step-by-step mechanism to see what tool was called, what query was inserted, what were the input and output, what were the latency of each and everything. So let's go ahead and look at that in the UI to see what it looks like. So here my manual tracing. I have about 9 traces that I've used. I can actually look at all the latencies for all the traces I have. I don't have any errors. So let's go ahead and look at that particular trace and see what it looks like. All right, so this, I believe, is my query. It took about 12 execution. If I click on that and I look at the dateline, you can actually see now this is the query. The RAG pipeline was the top level chain. It called parse query, which tells me what the inputs and outputs were. It then called embed query, which actually returns you the vector of documents in the floating points, which I then send those vector to my search. And this is my inputs to the search. These are the outputs returned that match this particular embedding closely. And then I format that. This is my input. These are my documents that I used, and that's what the output was written as a final thing. And then I generate the answer, and this is where the output is actually generated, giving a nice little answer. I can actually look at each and every call to see where my latency is and which was the call that actually took long. And then based on that, I can further tune it. I can look at my attributes, tokens used. I can go to each and everything and then look at the attributes. I didn't set any attributes over here. I can look at those attributes over here. Top level 3, these were the embedding dimensions. I can embed the query and look at those attributes. I don't have parse query. If I set the attributes, all those would be over here. So this was essentially an end-to-end RAG that used this manual tracing to give you more granularity into what are some of the things which actually happen behind the scenes. So finally, now I'm going to sort of do the advanced debugging techniques, which we got a huge glimpse in the video for tutorial 3, how to actually use the Claude ML assistant to debug your traces. So I'm going to have that leave you as an exercise. But what I'm doing over here is I'm actually creating a function with some deliberate bug where I'm sending in the wrong arguments. And this will actually return a fail with an exception that I have a missing required argument. And what I want you to do is go to the particular trace, do the filter by saying select the command of type state. So let's look at the state. And I want you to select error. I want to apply the filters. So I got my state. Click on that. Go to the MLflow assistant. And then ask the question, do some root cause analysis on this trace and suggest how to fix it, right? Go ahead and do that. Click on this, and then this MLflow assistant will go through this particular trace and give you the recommendation. Whatever the recommendation is, look at it, go ahead and fix that. Now let's go back over here to our final bit over here. We collapse this. Finally, using traces to identify bottlenecks. What we have actually done is use these particular MLflow trace decorators to get more granularity in the span and visually look at what it is that the span is doing behind the scene. So when I run that, I'm going to get the ability to look at the timeline for each and every function that was called. I can look at the aggregate metrics such as span types, all my P50 and P9 latencies. And I can look at the success rate per operation. I can compare some of the traces that I actually want to look at in terms of A/B testing to see what functions did better. I can optimize my strategies by looking at the embedded generation, or maybe use a different tool to create it out. I might optimize my vector search. I might use my prompt for GEPA, and then look at some of the LLM calls which are slower to maybe substitute with a smaller model. And any of these traces and more granular data gives you the ability to debug and optimize your agentic workflow. So in summary, what we covered over here, we really get into the difference between when to use manual tracing, when you actually want to have more granular data. Some calls that the autologging won't cover. You use the MLflow trace decorator and you provide a particular name and then assign the type of span that you're actually interested in that particular decorator to be. You can assign some custom attributes by doing the span set attributes. Those could be searchable in the trace. And this is a good way to sort of create end-to-end pipeline for your RAG. And we also discovered how to use tracing agentic workflows using tune selection and some advanced debugging techniques by just looking at all the particular traces. So takeaway is that combine autologging with manual traces to get a complete coverage and look into the observability, use the span types and look at the UI to see where the bottlenecks are. Add custom attributes for debugging analysis, and build chain hierarchies for your complex workflows so you can group those operations together and trace everything from retrieval to generation to validation. In production best practice, always do tracing in development and staging, more into the key metrics from traces, latency, errors, cost, token usage, set up alerts for anomalies, and then retrieve traces during the incident response. So that was the end of the 2 tutorials specifically focusing on MLflow tracing, which is an important pillar as part of the MLflow GenAI platform. So hope you can join me again for the next tutorial where we talk about prompt management and optimization. Thank you.